Hello everyone and welcome back. I think that this video will be one of the most important for your data science career because almost everyone can copy and paste code from internet and train a 98% accuracy model. But what's the difference between that guy and the real data scientist? So who is a professional data scientist and what makes a data scientist, a professional data scientist? Right after the intro. And welcome back. So, let's say that anyone can open a notebook, follow a tutorial on YouTube, and train a 98% accuracy model. So the question arises, why do we still need real data scientists? Why? It's true, you can find all the resources online, you have libraries, pre-made templates, there are lots of tutorial, lots of articles, lots of projects you can take inspiration, you can follow. But are you real scientists only if you learn from these resources, only if you use these resources? The answer is no, obviously. And in this video, I want to show you 4 things you need to consider if you want to be a real and better data scientist. So, the first thing is the risk of using out-of-the-box libraries. The second thing is that it's all about assumption in the data scientist job. The third one, it's all about critical thinking and common sense. And the last one is that data science is an art. So let's start with the first one. Risk of using out-of-the-box libraries. As data scientists, we use a wide number of libraries and tools that ease our work, like Pandas, sklearn, TensorFlow, Keras. These tools allow for a smarter way of working, simplifying operations that otherwise will need more effort. But this comes at a cost, because you can end up using libraries as black boxes without even knowing what you are doing and what it is under the hood. So I'm not saying that you don't have to use the tools, but you need to understand exactly if and why a particular approach suits a particular situation, and how the techniques you're going to use works. So you should start, for example, by implementing techniques from scratch to better understand how this technique works, and then move to use libraries. Because only by knowing different techniques you can pick the best one, and to know different techniques you need to fully understand all the technical and mathematical details of the techniques. Libraries and tools should not lead us to ignore theory and forget important technical details. This is the first take-home message, and it's very, very important. Let's move to the second one. It's all about assumptions. From cleaning and preprocessing to machine learning, we can apply different techniques. The choice is generally derived from data, taking into consideration the goals of the analysis in a data-driven fashion. The fact is that almost every technique and algorithm has its own assumptions. An assumption cannot be violated, because if you violate assumption, you will end up with a wrong and meaningless analysis. You have to throw your work away. Some assumptions concern data, and other comes directly from mathematics and statistics. And remember that mathematics and statistics are the basis of almost all the algorithms and technique. Doesn't matter if it's a neural network or a logistic regression, maths is always there, and maths and statistics carries assumption. We might find ourselves in a common situation. So we have a model with high performance, which is good, but invalid from a statistical or mathematical point of view. And this because tools and libraries cannot tell us whether the assumptions are met or not, because this is the job of a data scientist. This is the job of a data scientist, and it's very difficult because you need to know different techniques, fully understand these techniques and all the assumptions. For example, naive Bayes assumes that features are independent from each others, which is called the predictor independence. Logistic regression, another technique, assumes error independence, linearity of the logic for continuous variables, no multicollinearity, and the absence of strongly influential outliers. These are things you should know, and you know only if you study the theory and the maths behind the techniques. Remember also that modeling reality is complex, and we don't know what. And if we don't know what we are doing, the result will be messy. And this could be a problem if you are a data scientist for your career. Let's move to the point number 3. It's all about critical thinking. Data science is never, and I say never, a linear or straightforward process. As soon as you discover something new, you must go back and ask new questions, because questions are the heart of a data scientist's works. Only by asking questions do we find other questions that perhaps lead to an answer. As a scientist, we must always question ourselves and our analysis. Only critical thinking and common sense allows us to arrive to unexpected results. This is very, very important. Libraries and tools, as powerful as they are, do not suggest the next step for us. We need critical thinking, we need experience, we need common sense. Let's move to the last point, last but not least, data science is an art. If you are wondering why, data science is an art because it requires originality, common sense, and critical thinking. Basically, we need a creative spark. In visualizing data, in reporting data, in storytelling, in choosing the right approach, in researching. You also need to keep in mind that having practical tools that we can use does not imply knowing how to use them correctly. And this is very important. Another important point regards the varied nature of data that requires curiosity and inventiveness. We need always to do a little bit more. We are always to look behind the scenes. We always to look under the hood. Tools and libraries cannot in any way replace the intuition and experience of a data scientist. And the only way to build that experience is to get your hand dirty, to have your hand dirty and work, make projects, and build your own experience. So at the end, what is the take-home message? Today we have advanced tools that do some of the works for us, but the risk is that we forget the basics and take things for granted. This behavior is very dangerous because it can lead to incorrect analysis. Using tools is fine as long as we know exactly what we are doing and why. It is important to understand that scientist's job involves curiosity, creativity, criticism, experience, and common sense. These 4 points are really important if you want to start your career as a data scientist. Always keep them in mind, always go behind the scenes, under the hood, and try to fully understand the techniques, the libraries, and the tools you're using. Only this way you will be a good professional data scientist, independent from the library. So you can switch library, you can go in a new company using new libraries, but you know the theory behind. And this is very important, will make you a real data scientist. Thanks for watching and see you in the next one. Bye!